we okay, but if you run into technical difficulties, we'll switch over to a pre-recorded presentation that they provided as a backup. So if that happens, please hang tight. So Elliot, are you ready?
I'm ready. I just a disclaimer. I'm feeling quite under the weather today. So for purposes of brevity and saying what I want to say in my presentation, I'm going to play my pre-recorded presentation. If that's okay, I hope it is. So I'm gonna do that right now. Jen, if you could just send me a message letting me know that you can in fact hear this, I would appreciate it.
Yeah, sure.
Okay.
Okay. Yeah, we can see it clearly.
My presentation. My name is Elliot Biltekoff, and my advisor is named Dr. Matthew Bolton, who has been helping me with this project for quite some time now, so thank you. This lecture will be covering fuzzy inference system model using virtue ethics for preventing and understanding moral injury. So, we have the problem, moral injury. Moral injury occurs when an individual perpetrates, fails to prevent, witnesses, or learns about acts that transgress deeply held moral beliefs, codes, or rules. Moral injury has been identified as a significant problem in particular populations that have a high exposure to potentially morally injurious scenarios, more so than other populations. And this can include people with occupations such as being in the armed forces, law enforcement, or medical fields. You could probably imagine some others. However, the literature also supports the idea that moral injury is a phenomenon which can lead to various negative ongoing cognitive affective states associated with things like PTSD, depression, etc. And this is especially true in individuals with shame proneness and or neuroticism. This idea is worth noting as it extends the importance of studying moral injury to people outside of high exposure occupations, which is actually the vast majority of the population. Exact mechanisms are not yet well understood. However, general characteristics of potentially morally injurious scenarios have been identified, and these are betrayal, transgressions of self, and transgressions of others. This is essentially a three-factor, which is originally a two-factor solution to the definition of the construct of moral injury, which has been posited in the literature. And it actually originally in the two-factor form was only betrayal and transgressions of self. Moral injury is an understudied area, and there's pretty much only intervention methods due to the fact that to prevent something, you need to be able to predict and understand it. And really only in the last roughly 10 years or less have attempts been made to actually operationalize and engage with moral injury as a distinct construct. So, how can we predict and prevent moral injury? Well, we can use modeling. So modeling is important because it allows for potentially very accurate predictions. And as I mentioned previously, in order to develop preventative measures for something, you need at least some degree of predictive capability to be able to know when it's going to happen with a degree of confidence. So individualized models and individualized modeling process can allow us to accomplish this, as morality can manifest really differently for different people with nuance and potential contradictions. So we want to use modeling for prediction because how and why people make particular moral assessments in particular circumstances, those are both important things to us. And we can't really compromise giving up one or the other. We want both. So, how do we proceed? Well, the main question we have to ask here is, what is the right way to approach modeling moral reasoning? Well, the answer is really a theoretically grounded approach. And by this I mean in respect to and drawing from both philosophy and cognitive psychology, which will enable the discovery of knowledge that will facilitate two research goals. And those are to provide low-level insights into the process of moral reasoning itself, so that way we can understand how moral injury can occur and therefore be able to estimate when or if it will. And additionally, we want to facilitate the development of computational tools that will prevent or mitigate, at minimum, moral injury. So how do we approach moral reasoning? So how do we think about and represent this? So Kant, Mill, and Aristotle, three big names in philosophy, and they've respectively each contributed, developed deontic, utilitarian, and virtue ethics-based approaches. So deontic logic, it has to do with permissibility and obligation, but it doesn't permit the postulation of genuine moral dilemmas. This is a big problem in terms of being able to investigate moral injury, because transgressive actions could be committed or omitted in a scenario which actually is a genuine moral dilemma. So we can't look at those situations, and that's a big problem. Utilitarian approach actually has arguably an even bigger problem, because it's based on maximizing expected utility of alternatives. It's consequentialist, so it's concerned with outcomes. But the thing is that the right thing can be done for the wrong reason, and that can be a major component in considering whether or not moral injury may occur. So that is arguably an even bigger issue. Virtue ethics. So a virtue is essentially a concept which is inherently good. So an action is virtuous if it is taken for its own sake, hence inherently good. And essentially the continuous well-intentioned pursuit of such actions, that's what it means to be moral. And the issue here, which is actually what we're viewing as an opportunity, is that there are not existing methods for computing with this ethics framework. So let's dive into virtue ethics a little bit here. So again, there's this barrier of no computational basis. That's a problem, obviously, if we're trying to build computational tools to predict stuff. So without an existing method, real situations can't be captured or hypothetical ones postulated, such that the corresponding representation can be computed with to reach descriptive or predictive conclusions. So that means that ultimate conclusions, as we see here, a couple examples, these can't be reached in a way which can be traced and explained within a computational model. And that's something that we want to do. So we need to find some way to provide a computational basis. And leveraging the expressive power of fuzzy logic to provide this foundation, it's a strong potential solution. And I'm going to explain why. So, fuzzy logic. What is fuzzy logic? Well, its initial formal structure and basic postulates were posited in a 1965 paper by Lotfi-Zadeh. This is an incredibly cited paper. I mean, it's got tens of thousands, if not hundreds of thousands of citations. This is the catalyst that started it all. It's titled Fuzzy Sets. And this is a quote from Zadeh himself. Really interesting person. I recommend looking into his work. It strongly inspired this. So one of the principal contributions of fuzzy logic is providing a basis for a progression from binarization to graduation, from binarism to pluralism, from black and white to shades of gray. I feel as though this quote really captures the essence of what fuzzy logic is about and what it enables you to do, and types of problems that expands your ability to think about. And it does this because fuzzy logic replicates the way that people seem to reason about concepts that don't have strict boundaries or are imprecise or might have different meanings depending on who you ask. And in such a global society that we live in now, this idea to be able to capture that nuance, that's really important. And so because of that, it actually lets us map feature states of the world to categories which don't have clearly defined boundaries. So this process of mapping feature states of the world, uh, well, it's called precision. So it's basically, in a very abstract sense, the process of precisely, using mathematics, representing imprecision, which is inherent when we're using linguistic terms like maybe low or high or fulfilled or unfulfilled. That's called precision. So precision means to essentially capture meaning of imprecise terms. Imprecise terms, what could those be? Well, linguistic variables, such as temperature. So for this example here, we're using temperature, but linguistic variables such as temperature are represented using natural language labels. So these are words like cold, mild, hot, which are mapped to values along a continuum. So for example, 0 to 60 degrees Celsius, using what's referred to as a membership function that has a given shape, and these can take all sorts of shapes. But the most common are triangular and trapezoidal, but you can also use sigmoidal or even piecewise functions. But these have different implications. So a membership function is really important, probably the most important thing here, because this is what exhaustively describes what is termed the degree of membership from 0 to 1.0, that all values within that continuum belong to a given category. So for example, a temperature of 5, if we look down at the graphic here, if we look at on the x-axis there, if we look at where a temperature of 5 is, that corresponds to a cold degree of membership of 0.75 roughly, a mild membership of approximately 0.25, and it doesn't belong to hot at all. And these membership functions, these are what we would produce through that aforementioned process of precision. And a specific membership function over a given continuum, that is essentially what constitutes a fuzzy set. So if we want to consider virtue ethics and fuzzy logic together in aggregate, like how can we use these two things together to solve our problem? Well, there are a couple important points that need to be discussed. So there is an irony here. Some of you might be familiar with Aristotle and his work. So he's actually a strict dichotomist and serious proponent of binarism. Like he's kind of one of the biggest proponents probably ever. So this work is kind of funny in a way because it uses some of his philosophy as an underpinning, but it's really doing away with his approach to deductive logic because it doesn't uphold the desired requirements that we're seeking in a technical implementation, which reflects our existing and current knowledge of how people actually reason and evaluate, which isn't in a super dichotomized way, these shades of gray that we discussed before. So we can think about this in the sense of no scenario is ever actually completely ethical or completely unethical. That's an important point. So the explainability and fidelity of a model of moral reasoning, we can't compromise that. And the distillation process of dichotomization loses a lot of the information and nuance necessary that will help truly understand morality and the processes it's involved in, moral reasoning, moral injury. There is also a need for modernization. So Aristotle's original superset of virtues, that was for male Greek upper class individuals, right? That is not going to work. So we need a much more globally relevant underpinning in terms of what our superset of virtues that we will be considering. And the moral foundation theory, this is a much more contemporary theory, which provides a superset of 5, possibly 6 universal concepts, which you can find listed below, which all cultures and societies essentially derive their senses of morality from. And we can treat these in the same way that we have discussed virtues thus far. So these two things in conjunction, they have some really synergistic qualities that we are desiring here. And these are, it's explainable, can provide an explainable result, an output that is in both linguistic and mathematical terms, or rather linguistic or mathematical terms. It's flexible, we can apply it in different contexts. It's extensible, it can develop new and refine existing capabilities. And it's very important here, computable. So we can actually build models using fuzzy logic that are using the concepts of virtue ethics. And essentially what this will do is we can inform the model by giving it input with the scenario, which is comprised of a collection of objective feature state values as inputs. And it outputs a representation of an individual's moral evaluation in terms of fulfillment of a virtue concept. So the actual implementation of the model is going to look very similar to this. So this is what's called a fuzzy inference system, FIS model. This particular type is called a Mamdani type. And it's comprised of a few major components here. So we have a crisp input. These are non-fuzzy numbers that we're inputting into the model. We have a fuzzifier. This is a process which converts these crisp input values into fuzzy sets, which are then sent to the inference engine. The inference engine, it's basically a set of conditional if-then rules which get applied and perform operations on fuzzy sets. And each of these rules results in an output of a fuzzy number. You could think of these rules things like, if a car's speed is very high and pedestrian traffic is high, then acceleration should be very low. We then have the defuzzifier, which takes the fuzzy output from the inference engine and converts it back into a crisp output using what's called an aggregation operator to combine them all and collapse them into a, once again, non-fuzzy number. And it should be noted that the knowledge base, this is essentially the information extracted from a participant in a study, which would inform the fuzzifier, inference engine, and the defuzzifier. So what's going to be our general methodology in terms of how we're going to build an FIS? Well, we would start by procedurating model components. We do that by presenting propositions to subjects in order to elicit from them via self-report best estimates of our membership function parameters and the inference rules for the inference engine. So this is really, we're informing the fuzzifier and the defuzzifier and the inference engine. We would then expose the subject to scenarios and have them evaluate its features, as well as the fulfillment of the relevant universal concept or virtue. And we would have them do this using the linguistic terms for which information has been captured, and thereby meaning that those terms have been procedurated already. We use that data in order to validate the model using fuzzy logic supported k-fold validation methods. And we also want to consider constraints on the model and methodology itself. So it doesn't really make sense to just throw a bunch of numbers at people, permute to the entire state space. That's not really possible, and it also doesn't make intuitive sense. Because some virtue concepts are clearly not relevant in some situations, and maybe the bounds of feature state value ranges could be constrained depending on context, etc. And also, we can probably collapse the potential model space using existing knowledge from cognitive psychology and previous applications of fuzzy inference systems, specifically having to do with how people integrate and evaluate features. Maybe certain membership functions work really well, maybe some don't. These are things we can consider. So in conclusion, there are insufficient existing methods for comprehensively modeling moral reasoning in humans, particularly in the context of trying to understand and prevent moral injury. And we want to provide a theoretically driven method for eliciting, capturing, and computing with models of moral reasoning for the purpose of developing further understanding of and preventing moral injury. Thank you.
Great, thank you for sharing us a clear explanation about fuzzy logic and theory. So, so Dan, do we have questions from the
We have
audience?
no questions in right now.
Oh, okay. So we'll leave the chance for the panelists right now. So who have the question, you can just go ask Elliot directly.
Yeah, and if there's no time right now, we can definitely move on. And if there's time at the end, they can ask, or you can follow up with me via chat or the networking directory.
Yeah, exactly.
Thank you all for listening.
Okay, so if you do have any question, you can just type in the chat or the Q&A. So we'll follow up the question probably at the very end of the session. Okay, so next presenter, Olamide, right? Are you ready?
Yes, I am. It's Olamide. Thank you very much. Yes. Hi, everyone. Just 1 second while I try to.
Yeah, sure.
Okay. Hi, everyone. I'm Olamide Olatoye. I'm from the Advanced Interface Design Lab at the University of Waterloo, supervised by Professor Kathryn Burns. And the title of my research that I'm presenting today is User Study for Implementation of a Sepsis Clinical Decision Support System in Pediatrics. This research was done in Systems Design Engineering departments in collaboration with the Sepsis program at Sick Kids Hospital in Toronto. So the background, according to the most recent definition of sepsis, it is a life-threatening organ dysfunction caused by dysregulated host response to infection. Sepsis can lead to tissue damage, organ failure, and ultimately death if not treated early. So to provide the best care for sepsis, early detection is important. With every hour of delay of care, mortality is increased by 5 to 10%. So one acronym that I'll be using a lot today is BPA, which is Best Practice Advisory. And these are clinical decision support tools incorporated in electronic health records or electronic medical records of a healthcare organization to bring clinicians' attention to a particular element of a patient's care. And in the case of this research, that's a patient at risk of sepsis. So for the motivation, studies have shown that alerts and EHRs are often ignored or overridden by clinicians because of poor interface design, low specificity, unclear information, or workflow disruption. There's also very little research, including human factors or user studies, to inform the design and implementation of clinical decision support systems, especially in general pediatrics care and with regards to sepsis. In addition, in the pool of research, detection and prediction of pediatric sepsis is underrepresented. So a quick system overview. The study was carried out at a pediatric care hospital where management was developing a sepsis best practice advisory for the general pediatrics unit. The tool is to be integrated into EPIC, which is the EHR system in use at the hospital. There's also an existing sepsis early management pathway currently in place for the care of patients with sepsis, and this tool would be supporting that pathway. So what were the research objectives? And first, to explore clinicians' decision-making regarding identification and management of sepsis. 2, to elicit user requirements, their perceptions and expectations regarding the sepsis BPA to be implemented. And 3, discover usability challenges, clinician satisfaction, the acceptance and intention to use the sepsis BPA through moderated usability testing. 4, we'll be using the results from 1 to 3 to provide recommendations for design and implementation of a sepsis BPA in general pediatrics care. So just a quick look at the method. First, another acronym that I'll be using often in this presentation is MVP, which stands for Minimum Viable Product. And it is just describing a functioning prototype of the tool that was developed at the time of this study. Ethics approval was obtained from the University of Waterloo for this study, and the study took place in 2 phases. There's the first phase, which was the semi-structured user interviews, and then the second phase, which is the moderated usability testing. So before I go into details, I just wanted to give a quick view of the tool. So here is the pop-up that clinicians see to alert them to a patient at risk of sepsis, where we have a total score, we have the criteria for the scoring, and what clinicians have to do is click yes, and then accept, and then takes them to the summary page of the patient, and then they click on sepsis hurdle activated, and then this takes them to the sepsis tool navigator. So here on the left, we can see the sidebar that has all of the details that the clinicians all the details sections that the clinicians are going to interact with to be able to carry out their make their decisions regarding a patient at risk of sepsis. So first, the semi-structured user interview. So for the methodology, we had 10 participants. Setting was remote. Questions were centered on decision-making regarding identifying and managing sepsis, the challenges they encounter, challenges clinicians encounter, expectations of the sepsis tool, and the design and interaction preferences of clinicians. I also carried out control task analysis using decision ladders to model clinicians' decision-making. So first set of results. So for active thematic analysis on the interview, we had 3 thematic categories with 10 themes. So the first category being in general experience and knowledge care for patients with sepsis, where clinicians shared with us how they identify and manage sepsis, what the experience with sepsis is, and the kind of actions and diagnoses that they carry as are very specific to sepsis. In the second category, we talked about challenges of caring for patients with sepsis in the local healthcare setting, that's in the hospital. And then they shared their barriers that they encounter in identifying and managing sepsis and their most challenging experiences with sepsis. In the third thematic category, they talked about the experience with clinical decision support systems and projections of the sepsis BPA. So they talked about their general experience with clinical decision support systems, and they also shared their expectations of the sepsis BPA and also the perception of the department that may benefit the most from the sepsis BPA. So first thing first, key findings from the themes were translated into user requirements, and there were about 20 of them, but I will just share a few with us quickly. So these requirements were checked against the MVP, that's the minimum viable product, and recommendations were provided. So a few of them I will just quickly share with us. So the first is the pop-up design for the alerts was the most preferred by the participants, as can be seen on the graph. The MVP has the alerts designed as a pop-up, like I showed us earlier. So that worked, but except that the tool triggers an alert only when the patient's chat is opened. This may not entirely address the need for the tool for situation awareness, as clinicians still get to be totally oblivious if they do not open a patient's chat. From the interview results, about half of the participants stated that they would want a concern for sepsis to, pop up in their faces when they're on EPIC. But some participants also mentioned having anchoring bias regarding sepsis in an otherwise healthy patient, meaning that, for example, at the beginning of their shift, if they check up on all their patients and they encounter patients that look or seem healthy at the beginning, so they have that anchoring bias that makes them to not check up on that patient as often as they would a complex patient, and this interprets into the fact that they might not open that patient's chat as often. So the design of the tool in that way do not address these problems, and the alerts should definitely pop up both in and outside a patient's chat. Then another most prominent preference for interaction communicated by users is an acknowledgeable alert, and the minimum viable product meets this demand because this is the pop-up that they see when they open the chat. Like I showed us earlier, clinicians click yes and then accept, and then they see the sepsis huddle activated banner up here, which they click in the summary page, and it takes them right into the sepsis navigator. But the recommendation provided here is that this is to make this interaction all into a single click interaction. That's from the pop-up to the sepsis navigator. So from the interview, clinicians mentioned not wanting or liking too many clicks and find them discouraging. And this is also a very dominant issue in literature and for electronic health systems, and avoiding too many clicks for this tool would improve the usability of the tool. So another is the criteria for the alert. So 9 out of 10 users stated that they would expect to see the criteria for the alert as the first piece of information. So the minimum viable product met this requirement, except that the display of the sepsis score needs to be redesigned to have the digits side by side, as opposed to one being on top of the other here. And also another recommendation is to have the total score included below, as opposed to being on top. That kind of helps the clinicians, in reading the pattern of the sepsis scoring. So another thing that clinicians shared with us in the interview are the concerns that they have about the tool, coming into their system. So one that I would like to share with us today is the one that stands out the most, even in literature, is alert fatigue, right? And here are the steps that the sepsis team are taking to address that concern. So first, the tool resets every 24 hours for patients that trigger the alert and have an activated huddle. This especially addresses complex patients, because patients that are complex most times usually have baselines that are below normal, so that the tendency to activate the alerts continuously is there. So this function tries to get rid of that alert fatigue. And then 2, sepsis score and criteria, although it was adopted from the US, it was customized to the hospital setting. So a set of experienced professionals in the hospital were able to sit down and customize the scoring and the criteria to the hospital, just to make sure that alert fatigue does not become a problem. Then 3, a background test of the algorithm with real patients have also been running in the background for about 2 months now, and alerting only members of the team to test the sensitivity of the tool. So on average, the best practice alerts alerted like 1.1 times per 24 hours in total for the unit. So that's about 1 patient a day. So the next set of results are the decision ladders. So 2 decision ladders were developed, the first one showing current practice for sepsis in the hospital, the left side being the situation analysis, and then the right side being planning and execution. So the nurses, especially the bedside nurses, are most engaged on the left than the right, and then the physicians are most engaged on the right than on the left. So here in this diagram, the red arrows show possible shortcuts in form of shunts and leaps that the clinicians take. And for example, the arrow with the label 1 shows a shunt from observed to procedure, which is reflected in the interview, where participants stated that they start antibiotics immediately for patients that are actively going into septic shock. Then here we have the new hurdle on the sepsis BPA. So with the sepsis BPA, there's a new hurdle, which the tool, helps the clinicians to follow. So with the new hurdle on the sepsis BPA, the tool supports two automatic shortcuts here. So from this shunt from alert to the system state, where the BPA pops up and they get to see the criteria, so they get to have knowledge of the system state, and then the shunt from evaluate to task, where the patient is evaluated and then they reconcile the sepsis alert based on that evaluation. So the next stage is the moderated usability testing. We had 7 participants. Setting was remote. It was a think out loud session, heavily qualitative study. And we had 2 case study scenarios as opposed to providing specific tasks, because we wanted to ensure that the tool supports clinicians' cognition and decision making. Then there was a post-study survey, which was a unified theory of acceptance and use of technology that were given to participants. So just because of time, so we found some likes and some challenges, some features that the participants liked and some challenges that they encountered, and we also provided recommendations. There are about a number of them. If you want to, learn about them, you can hit me up later. But because of time, I will just move right to the survey. So, so here are the results for each construct. So the Unified Theory of Acceptance and Use of Technology has 4 constructs, and we asked questions based on those 4 constructs to kind of get clinicians' perception of the tool. So here are the results for each construct. So starting with the performance expectancy, responses to these questions in this section are mostly positive, about just 1 to 2 participants providing neutral responses for 3 of the questions. However, most participants agree or strongly agree that the tool will be useful in their job. Then 2, the second is the effort expectancy. So there was only positive feedback about the learning experience of the participants while interacting with the tool, as we can see in the first and the third questions. So learning to operate the BPA is easy for me, and it would be easy to become skillful at using the BPA navigator. So that's positive for the learning the tool. Then this also confirms that the tool is intuitive. There are also very highly positive responses for most of the questions, confirming that participants found the tool easy to use. Then social influence. So for here we have responses in this section were, not as highly positive as the other 3 constructs. A significant number of participants provided neutral responses. This might reflect the fact that maybe social influence in the organization may not play a very strong role in clinicians' acceptance and use of the technology. Then the 4th being the facilitating conditions. So we had first thing to point out is that the negative responses in the second question cancels out the not. So there is a not. It says the sepsis BPA navigator is not compatible with other systems I use. So that means that questions 2 to 5 show highly positive feedback regarding facilitating conditions for the tool. Regarding the so for question 3, using sepsis BPA and navigator fits well with my workflow. So we had 6 participants equally, that's 3 each, agreeing and strongly agreeing to that question for the fit of the tool in their workflow. And this provides very good feedback for implementation. Then we have, lastly, behavioral intention. So here we asked only 1 question, and we asked them, I intend to use the sepsis BPA navigator over my current workflow in the next few months. And we had only positive responses. So all 7 participants either agreed or strongly agreed to use the sepsis BPA over their current flow for sepsis in general pediatrics. So conclusion, so the study contributes to bridging the gap between the development of sepsis, clinical decision support systems in pediatric settings, its acceptance and successful implementation by providing design requirements and clinicians' perceptions. It also highlights the importance of involving users in the design process and implementation of decision support tools in their workflow. So the next steps for this research would be to implement the recommendations and run a second stage usability testing to show more impact of the user study. So thank you very much. I would like to thank the sepsis program at St. Kitts Hospital for providing support and the environment for this study, systems design engineering for providing funding. And this is my contact right here, my email, just in case you want to reach out and discuss more on the research. Thank you.
Great presentation. Okay, so check with Dan that do we have any question from the audience?
No questions in right now.
Oh, okay. So I do have one question for you.
Oh, okay.
So how do you like settle down the components in your interface design?
Oh, okay. So when I was coming on the project, the design team, like the sepsis team at the hospital had already developed the minimum viable product, but they did not particularly do a user study. It was just like meetings with like stakeholders and just some representatives in the hospital. So I just came in to say, we should try to have a user study to, try to get more feedback from the users before this tool is implemented into their system, to try to see if it actually fits into their workflow, what kind of maybe workflow changes that we might want to make, what kind of changes we might want to make to the design to make sure it's really works for the clinicians. So I wasn't totally involved in like building the interface, but I was able to carry out some heuristics analysis, give some feedback, incorporate users' requirements into giving that feedback to the design team to be able to make adjustments and corrections.
Gotcha. I do see a lot of efforts, like how you settle down the usability tasks and the efforts to choose the methodology there.
Yeah, thank you.
All right. So yeah, that is all the time that we have for Aladama's question. And if there's more time at the end, we can come back to you. And but if you still have questions from the audience for Olamide, and please feel free to contact her directly. And her contact information is in the networking directory. Okay, so next up is Ryan.
All right, hi. 1 minute, let me just set up.
Yep.
All right, you should see the slide. Perfect. All right, good afternoon, and thank you for joining today. My name's Ryan, and I'm a second-year master's student at the University of Waterloo. This presentation is on some exploratory work conducted in the Advanced Interface Design Lab, exploring information management and health communication in complex home care, a qualitative study. The research in this presentation is part of a broader study on the design of digital health tools in complex home care across age groups and caregiver types. But for this presentation, I'll be specifically focusing on the work domains of families of children with special healthcare needs. So home care is rapidly changing our healthcare system. On average, family members in Ontario spend 20 hours per week for 4 years supplementing healthcare services in the home and purchase approximately 20 million extra visits or service hours, which could include nursing, personal support, therapy, supplies, equipment, and other services. In 2015, there were a total of over 29 million hours of personal support care provided to over 700,000 individuals, where the care is often complex. So the Community Care Access Centre in Ontario, Canada, defines complex care as medical, physical, cognitive, and social conditions that are at risk for hospitalization, chronic conditions, unpredictable care needs, and the support for a support network. But with advancements in medical technology, the life expectancies for children with complex health needs is rising, where more than 15,000 children and youth in Ontario are currently living with complex chronic health conditions in their home. With the rising complexity in home care comes the increased risk for adverse events. In Canada and the United States, the annual incident rate for home care patients who have experienced an adverse event, such as a medication-related incident or an infection requiring rehospitalization, has been estimated to range between 4.2 and 13%. Fortunately, it is suggested that more than half of these adverse events that occur could be reduced by 2 ways. One, by improving inconsistencies with care, where there may be ambiguity in roles and responsibilities of caregivers, coupled with poor documentation processes. And 2, by preventing communication breakdowns, where there may be limited health literacy of caregivers and poor communication among the care team, the care recipient, and the family caregiver. One proposed way of improving these aspects of patient safety is through the integration of digital health technology, where there is significant literature that in-home electronic health record systems could support standardizing communication and providing efficient access to information in the home. However, there are currently no substantial technologies used in this domain, and annual adoption rates for systems such as online portals have been reported to range from 5 to 12.4% due to usability issues and the inability to meet the complete needs, information needs and communication needs of caregivers. So to address the gap in designing effective digital health tools for complex home care that meet the needs of caregivers and support engagement, one of the objectives of this research is to provide an in-depth evaluation of the current work domains of family caregivers of children with special healthcare needs in North America to better understand their diverse experiences with information management and health communication in the home. So in this study, we used semi-structured interviews and analyzed our data using an inductive theoretical approach. There were 7 family caregivers who participated, and all of our participants identified as female. 5 were located in Canada from the provinces of Alberta and Ontario, and 2 were from the United States, located in Missouri and Minnesota. Our youngest participant was 33 and our oldest was 44 years old, and they had a wide range of caregiving experiences. So from our inductive analysis of our qualitative data on caregiving work domains, we identified 5 themes and 4 sub-themes that describe the information management and communication processes of the family caregivers in this study. So family caregivers discussed that they were continuously learning to provide care in their home. They were updating the caregiver team on their child's status by maintaining records and while strategizing care with their child's healthcare team, and faced significant pressures with sharing the right information with the right person at the right time. Family caregivers were caregiving educators, where they spend considerable time teaching caregivers about the nuances of their care situation, which came with challenges in building educational materials and pressures in knowing if their methods were effective. As caregiving teams grew, they found themselves needing increased communication beyond their child's teachers and other educational staff. And beyond the scope of managing their child's health information, an important challenge that family caregivers faced involved navigating the bureaucratic processes of home care, such as scheduling and payroll, to support the coordination of the care in their home. So there are 3 principal findings that I want to highlight from the analysis of complex home care for children with medical complexities in their home. First is regarding the geographic location of our participants, where information supports and access to formally trained hired caregivers were either abundant or unavailable. For example, while life-supporting medical equipment is often a significant component for families of children with complex needs, some families in the United States were not afforded the necessary instruction or formal training and took on considerable responsibility to ensure the safety and quality care by learning to use these devices on their own. For example, participant 5 said, "With our suction machine, when we initially came home with it, the day of discharge from the hospital, I was handed the suction machine. Here's your machine, go home, bye. Nobody showed me. I've never seen a user manual for those things ever. At that point, I'd gotten used to seeing them in the hospital, the wall-mounted suction machines. I kind of had a basic idea, like, okay, can somebody at least show me how to turn it on?" So one similarity between some of the geographic locations was having access to medically trained hired caregivers for respite care. So while some caregivers do receive significant support in this aspect of care, others navigate the hiring process, medical training, and supervision of hired caregivers independently. The additional challenge and hours of training required to sometimes teach a stranger who has no medical experience places considerable pressure on family caregivers for how they manage information and communicate in their home, where a majority of family caregivers will quit their jobs to stay at home full time. So second, the dynamic nature of complex home care, especially for children, is a result of the changes of their child's health, their required support, and their caregiver teams over time, leaving family caregivers to continuously learn and share new information to keep up. So as a result, the information that they record at the onset of becoming a family caregiver may change from documenting vitals to recording more holistic aspects of care like behaviors and feelings. In some situations, less information is recorded, where documentation is only necessary when their child is showing unusual symptoms, and there's a need to identify the underlying patterns and trends to support clinicians. The methods and tools used to support these dynamic processes must either adapt to the changing workflow, or the family caregiver must create new methods to support these changing tasks on their own. New challenges also emerge for navigating two-way communication while their child is attending school. So technologies such as email, voicemail, or written notes in their lunch pail may suffice as information exchange methods between the home and the school, but concerns are raised with privacy, and there's a lack of communicating detailed insights beyond messages that just say, your child had a great day. The design of online portals and other communication technologies have not considered these specific caregiving needs. Participant 4's experience with constantly updating caregivers created significant stress when she said, there are always people adding and incoming, and it seems like it's always on the parent to fill in the next carer, the next professional, on what's going on, and answer their questions of what they might have from the previous professional. And it all comes down to the whole concept of the parent is the expert in their child. But we shouldn't have to be that role all the time, and that's very frustrating. We have team meetings at the school once a month with teachers and board members and all that stuff, and I'm expected to come in with my binders of information and fill them in on everything that's happened in the last month. It's crazy exhausting. It was stressing me out considerably. Third, understanding the work domains of this population identified a significant cognitive burden for family caregivers to accurately and concisely share complete information regarding their child's health to other caregivers. So information sharing situations occur within caregiver handoffs in the home, at caregiver team meetings in clinics and schools, and with their child's doctors and specialists. So digital healthcare tools have a significant potential to reduce the pressures on family caregivers while managing their child's information. And based on the principal findings of this research, and to encourage engagement with digital health tools, the focus should be directed towards designs that, one, reduce the need for family caregivers to manually organize their collected information. Two, provide timely access to information, insights, and patterns specific to the context in which they're interacting. Three, allow for customization to meet the unique needs of complex home care over time. And four, offer a shallow learning curve for effective interaction by all caregivers. So transferring to a virtual environment due to COVID-19 supported this study's wide online outreach to capture diverse caregiving experiences. However, the demographics are limited. This exploratory research provides further insight towards designing digital health tools to support caregivers in complex home care domains. And future research should build on this work by including broader demographics and directly studying caregivers' interactions with a digital tool in a home care context. That's the end of my presentation. Thank you for your attention today. I will now open the floor to any questions, or feel free to message me after this. Thank you.
Great, thank you, Ryan. And if you do have any question for Ryan, please put them in the Q&A feature. So we just wait a few seconds for the audience to type in their question. So do we have any question from the panelists right now? Okay, so sorry, I will always be like so curious about the device design thing. All right, so I do have like several questions for you, Ryan. Is that
Sure.
Like first, how do you possibly like reach out to the, the users around, Canada and the US?
Oh, okay. Yeah, that was actually a really interesting experience. So there's a lot of caregiving networks that exist.
Mhm.
So reaching out to those, they have connections usually with caregiver support groups, and they provide resources to caregivers to support them with their home care, figuring out what to do, what resources do they have access to. So kind of reaching out to those organizations have helped. There's also been support from reaching out to hospitals who also have usually like a caregiving group or a committee that kind of supports families when they're being discharged from the hospital. So they provide them with these resources sometimes to help with that. And honestly, other methods that I use to kind of help with recruitment were just to look at Facebook groups. There's a lot of Facebook groups that exist online for families who are caring for a child with special needs, or caring for even maybe an older adult who has diabetes and needs special care in their home. So getting permission to post on those groups from the administrator does also help with outreach to get participants.
Gotcha. Great.
But good question.
Yeah, thank you. So then I do see a question that posted in the Q&A, right?
Yeah, we do have an anonymous question that came into the Q&A. It says, I may have missed this, but do you have any plans for translating your findings or recommendations into specific designs?
Yeah, that's a good question. So this was kind of like a first step into figuring out what could digital tools look like. The second half of this study included, I guess, a modified Wizard of Oz study where caregivers were interacting with a potential designed tool that existed of a voice assistant, so kind of like your Siri's or Alexa types of things. So I was looking at the design, okay, can the design of a digital health information exchange platform in the form of a voice interface be a more effective and engaging method to interact with health information in the home? Because current research kind of identifies the fact that even mobile health applications, while the idea of them is very intriguing and interesting, and especially families of children with medical complexities are really interested in any kind of resource that can help them manage their information. Often the adoption rates for those are also low, where they'll have usability issues. The fact, even in Olamide's presentation, talking about the number of clicks, just that physical interaction component is often a burden when they're providing physical care in the home. So is augmenting that app, maybe through a voice interface, a better way for them to provide aftercare, where if they're caring for their child who is currently having a seizure and they need to record information such as the time that the seizure started, the position that the child is currently in, the medication that they've given and how much they've given, can they do that maybe through a verbal interaction with an application or a device so that they can still provide physical care to their child in those types of more critical or emergent scenarios.
Wonderful, thank you. John, how are we doing on time? Do we have time for one more, or should we move on?
Yeah, we have time for one more question.
Okay, so we have one last question from Juan, asking how/where do you think the findings can potentially impact the care design flow?
Yeah, that's an interesting question. So maybe one possibility could be during the period of a handoff of care, where the responsibility of the previous care is to provide information about the current status of the patient, the current medications that they're on, what's been given in maybe the last hour, and how the patient is actually doing in the home. Maybe a voice assistant could help with that and kind of relieve some of the burden on that previous caregiver to share all of that important information with the next caregiver that's coming in. There's maybe some potential for some of those intelligent aspects for it to be listening in on the conversation and chime in on if the carer maybe missed an aspect of communicating a piece of information, or reminding them that, okay, there is a scheduled medication dose at 2 p.m. this afternoon that needs to be given. There's a therapy session, maybe there's another caregiver coming in, maybe can kind of support some of those cognitive tasks during that care transition period. But that's a good question. Thank you.
Thank you.
Oh, that's really impressive. Okay, so that is all the time we have for Ryan's question. And if there's more time at the end, we can come back to you again. But if you still have questions for Ryan, so please feel free to contact him directly, and his and their contact information is in the networking directory. So next up is Kang. Oh, you can go ahead and
Thank
share.
you. Okay, thank you everyone. Let me set it up.
Yep.
Sorry. Let me go to the first page. Okay, can everyone see my screen?
We didn't see your screen right now.
Okay, wait a while. I'm sorry.
No, you're good.
Let me see. Okay, can everyone see my screen now?
Is that
Here?
only me that didn't?
Oh,
okay,
okay.
yeah, we can see your screen
There
right
we
now.
go.
Okay.
Okay.
Okay. Thank you, everyone. Hello, everyone. My name is Kang Wang, and I'm from IUW of School of Public Health and Health Systems in the University of Waterloo. My supervisors is Professor Shi Cao and Professor Plinio Morita, who helped me this project a lot. So, and my topic today is optimizing public health data collection from Internet of Things sensors and integrated data sharing platform. So today I would like to go through this agenda from these aspects: the background, object, methods comparison, potential benefits, applications, and future work. So as we all know, recently the Internet of Things devices has been widely used in healthcare and the public health. Since these devices can continuously capture health-related data or the data that may affect your health to support the remote monitoring, such as the heart rate, activity, and sleep ECG signal. These have been an essential source of data which helps the development of healthcare. And there are 4 V's described feature of the big data in healthcare. They are volume, which means the large scale of the data from a lot of devices. And second one is velocity, which means the streaming and real-time data from these devices. And the third one is variety, which means the data can from different sources and it can be different forms of data. They can be number, they can be signal, they can be like picture. And the last one is veracity, which means the truthfulness of the collected data. However, such abundant data also brings challenges to its application. Okay, under such condition, the great data challenge in public health research and practice, I think that is lacking standard and optimized channel to collect healthcare data from IoT devices and satisfy 4 V's principle. There are two current channels in collecting such data now. The first one is manual download and upload by data donors. And the second one is through some data sharing program, which is controlled by the device manufacturers, such as the DOID program created by the Ecobee company. So if we use these 2 channels, 2 main challenges we may face. The first, it will bring much operation burden to data donors. Secondly, researchers cannot get consistent data, which may restrict the real-time monitoring in healthcare. So some of IoT manufacturers make their user and device data available through application programming interfaces, which as we all know, it is the APIs. And an API allows a third-party program to access the database using software scripts. It can serve as a gateway for researchers and developers to access, to retrieve and store both historical and real-time data collected from IoT sensors. And it can be helped to implement the automatic data processing and transmission. So considering the need for standardized and optimized IoT data collection method, we aim to develop an API integrated data sharing platform that automatically retrieves real-time health related data from IoT sensors. For example, the heart rate data from Fitbit, ECG data from Apple Watch. So in this study, we also aim to compare our platform with current 2 channels I just mentioned before in previous slides. So the compare 3 methods, the first one is non-standard way that need data donors manual operations to download and upload. The second method is some data sharing program that provided by the manufacturers, such as DOID. And the last one is our proposed platform, which is integrated with API technology. And we will compare these 3 from these 5 scales: data completeness, data delay, data privacy, data donors usability, and the researchers usability. So here is a comparison. The manual method relies on active operations of data donors. Thus, the data completeness can be remarkably reduced due to operational errors during the complex sharing steps. Since this sharing process may occur once a day, it cannot provide real-time data, which will cause data delay. And in addition, the channel is not anonymized for donors, and their personal identifiable information can be leaked. From data donors' perspective, they may find difficulty to follow sharing steps, and their response rate will decline if it is a regular task. Also, the data is acquired from different donors, and the sharing process is not standard, which may cause researchers much time to integrate the data or organize the data. And the second method is controlled by manufacturers, which is not commonly seen actually. As far as I know, that is only one like program, such as the DYD that provided by the Ecobit company, but from the Apple company, they haven't have such program. And for the Fitbit, they didn't have such program also. So although manufacturers hold all users' data, which guarantee the data completeness, the data only be shared on a fixed interval time, and such as once a year. This still can cause data delay and set barriers for real-time data availability. And however, the data from this program is anonymized before researchers acquire, which can guarantee the data privacy. The manufacturers have simplified the operations for data donors, which only need them to assign a consent, and it will not take too much burden on donors, and also can increase their engagement. Besides, the data is pre-processed by the manufacturers before shared with researchers. So our proposed API integrated platform includes both user-friendly front-end and automatic working back-end. Completed data with accurate value is directly retrieved from the data pool of manufacturers with standardized data format, for example, the JSON format. And meanwhile, the backend scripts can run continuously to stream instant data without any data delay. And to ensure data privacy, sensitive information will be filtered, and a user-friendly interface will be provided, and the data donors can give their consent with just simple click operations on the front end. This is only one time. Also, this is only one-time authorization. And based on this, the platform can automatically retrieve the data with no more task from donors. For researchers, all data can be stored in a structured database without any additional process of data integration. So the potential benefits of using such platform is that it can increase the data completeness, also eliminate the data delay, and it protects the data privacy, and especially it can release the operation burden, especially for the data donors, also for the researchers, and it can raise participants' participation willingness and decrease the study cost, no matter from the time, also from the money. So the application of our platform is that it can be used to population level real-time public health monitoring, and understand the past behavior routines of patients or users, and provide them healthcare guidance. And also it can be applied to other healthcare studies which may need data from IoT devices. And in the future, quantitative metrics such as data completeness rate and delay time difference will be measured to evaluate each method. And also the statistical significance tests such as ANOVA will be conducted on measurement results. So that's it for today's presentation. Do you have any questions?
Thank you, Kang. And if you have any question for Kang, so please put them in the Q&A feature. So wait for the audience to type in their question. Okay, so Ari again, it's me again for the question.
Okay, sure.
Because I'm also using like the E4 wristband to acquire the ECG data. So I'm wondering like if you process the data from Apple Watch, right?
Yes.
Like what is the
like?
Yeah, all right. Sorry, go ahead.
Yeah. Okay. Like for this platform, we basically provide such technology to the devices which may have the API gateway. But for the ECG data from Apple Watch, actually Apple company, they do not support or provide such gateway gateway to the users or to the researchers. So we in our lab we currently use developing another toolkit to acquire the ECG data directly from the Apple Watch. As far as I know, that the health data acquired from the Apple Watch is actually stored in your local phone. So which means that your health application in your phone of Apple, it may be very big. So it is actually stored locally, and it do not provide the API gateway for researchers. And for other devices such as Fitbit or like Ecobee, air pollution monitoring devices, they do provide such API gateway to us, to researchers, so we can use such platform.
Okay. Wow, sounds pretty excited that you, even though the Apple Watch cannot give you what you want, but it still can develop the way to customize it.
Yes.
That's
yes,
really cool.
Exactly.
So I wonder if we get any question from the panelists. Like, feel free to, go for Kang. Okay. All right. So then we still do not have question from the Q&A feature, right?
Nothing from the Q&A.
Okay, cool. So, all right, I do have one last question for Kang. Can you foresee your proposed method and give us a case for its application?
Okay, sure. Like just for example, the project we are currently developing, like we are streaming the data from air pollution devices, and we all know the air pollution or the climate data. This data is very important to monitoring, especially for the seniors, for the aging people. So we streaming such data to create a data ecosystem, and we then use this streaming data, real-time data, then go to the machine learning models or some statistical models, and we predict some insight results, and just to get a very individual level monitoring, healthcare monitoring.
Wow, that sounds pretty wild. You also apply the prediction model.
Yes, that's the next step for analyzing such data. So the work that I'm currently doing is just like collect the data and support this data to the next step.
Yeah, I can foresee there's a lot of labeling things there.
Yes.
Okay, cool. All right. So thank you to each of our student lecturers and our audience for your questions. And there was certainly a lot of learning in this session, and we appreciate your contribution. I want to remind you that we are playing bingo throughout the day. So if you haven't started yet, please retrieve a bingo card from our website and join and submit your card by 4:15 for a chance to win a free student membership to HIVS, which I already got one. I mean the bingo card. Okay, so also please make a note for your impressions on this lectures, as you will want to vote for the audience favorite, most innovative, and most engaging lectures. Your ballot is on the voting page. So we are a little ahead of schedule, but our next event after lunch is our keynote lecture by Dr. John Lee from Wisconsin Medicine. And please enjoy turning off your computers and enjoy some downtime for the next couple of minutes. And we'll return from lunch at 1:30 p.m. to meet Dr. Lee. All right, see you guys around. Bye.